Scientific notation. Scientific notation is a way of writing a very large or very small numbers. A number is written in scientific notation when a number between 1 and 10 is multiplied by a power of 10. For example, 650 million can be written in scientific notation as 6.5 times 10 to the 8th power. We are going to write the following numbers in scientific notation. The number is 123. We need to place the decimal point between 1 and 2. So writing the decimal point between 1 and 2, it will become 1.23. Then we count the number of digits to the right of the decimal point. We have 2 digits, 2 and 3. This can be written as 1.23 times 10 raised to the 2nd power. Now we have 1,230. Again, we need to write the decimal point between 1 and 2. It will become 1.23. Counting the number of digits to the right of the decimal point, we have 2, 3, and 0. We have 3 digits. Therefore, the answer is 1.23 times 10 cubed. Now we have 12,300. So we need again to write the decimal point between 1 and 2. Then we count the number of digits to the right. There are 4 digits, 2, 3, 0, 0. So the answer will be 1.23 times 10 raised to the 4th power. Next we have 123,000. Again, we need to write the decimal point between 1 and 2. Then we count the number of digits to the right of the decimal point. We have 5 digits, 2, 3, 0, 0, 0. So the answer is 1.23 times 10 raised to the 5th power. Next, we have the last number, 1,230,000. We need to write the decimal point between 1 and 2. So we have 1.23. Counting the number of digits to the right of the decimal point, we have 2, 3, 0, 0, 0, 0. So this can be written as 1.23 times 10 raised to the 6th power. Now we have the following numbers. The numbers are all less than 1. If the numbers are less than 1, then the exponent of the given number is negative. So first we'll look at the first non-zero digit. The first non-zero digit is 5. We need to place the decimal point between 5 and 8. And we count the number of digits to the left of the decimal point. We have 1 digit, and that is 5. So the answer is 5.87 times 10 raised to negative 1. Now we have another number. We have 25 thousands. In 25 thousands, the first non-zero digit is 2. We will place the decimal point between 2 and 5. Then we count the number of digits to the left of the decimal point. We have 0 and 2, so we have 2 digits. Therefore, the answer is 2.5 times 10 raised to negative 2. Now we have 56 10,000s. Again, the first non-zero digit is 5. We need to place the decimal point between 5 and 6. So we have 5.6. And from the decimal point, we count the number of digits to the left. So we have 0, 0, and 5. We have 3 digits. Therefore, the answer is 5.6 times 10 raised to negative 3. We are in the next number, 258 millions. In 258 millions, the first non-zero digit is 2. We need to put the decimal point between 2 and 5. it will become 2.58. Then we will count the number of digits to the left of the decimal point. We have 0, 0, 0, and 2. We have 4 digits. Therefore, the answer is 2.58 times 10 raised to the negative 4. So we have a very small number here. So again, we need to place the decimal point between 2 and 5. It will become 2.54. Then counting the number of zeros, 1, 2, 3, 4, 5, 6, 7, 8. We will include 1. We place the decimal point between 2 and 5. So we have 8 digits. Therefore, the answer is 2.54 times 10 raised to the negative 8. Now, we have the following numbers. Write the following numbers in decimal notation. Since the exponent of the given number are all negative, therefore, the number are all less than 1. So we have 1.65 times 10 raised to negative 3. We have already 1 here. We need another 2 zeros. So the answer will be 0.00165. Looking at our answer, if we place the decimal point here, we count the number of digits to the left, 1, 2, 3. So we have negative 3. Next, the exponent now is negative 2. 1.65 times 10 raised to negative 2. We have already 1 digit here. We need another 1 zero to make it negative 2. So the answer will be 0.0165. Look at our answer. Since we place the decimal point between 1 and 6, from the decimal point going to the left, we have 1, 2. And that is negative 2. Now we have 1.65 times 10 raised to negative 1. We have already 1 here, so this can be written as 0.165 or 165 thousandths. Looking at the given, if we place the decimal point here between 1 and 6, so it will become negative 1. Now we have the following problems. So the problem now is 1,280. The first non-zero digit is 1. Then counting the number of digits to the right, we have 1, 2, 3. So the answer is 1.28 times 10 raised to the third power, or cube. We have 500,000. So we have 5. How many zeros are there? There are 5 zeros. Therefore, this can be written as 5 times 10 raised to the fifth power. Next, we have another number, 68,720,000. So the first non-zero digit is 6. So this can be 6.872. Now, from the decimal point, we count the number of digits. 1, 2, 3, 4, 5, 6, 7. So we have 6.872 times 10 raised to the 7th power. Now we have another number. This is hundreds, thousand, million. All right. We have 920 billion. So in 920 billion, we place the decimal point between 9 and 2. Then we count the number of digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is 9.2 times 10 raised to the 11th power. All right. We'll have the exercises now. I'm giving you time to answer the problem.
Always do it on my own, so I gotta get through it. And the only thing I know is to love what I'm doing. Never give up, never slow till I finally prove it. Never listen to the no's, I just wanna keep moving. Keep my head up when I act. back. I'ma keep myself on track, keep my head up, staying strong. Always moving on, feel I don't belong.
All right, we have the first number. The first number, we place a decimal point between 2 and 7. That is 2.75. Then we count the number of digits to the right. 1, 2, 3, 4, 5. That is 2.75 times 10 raised to the fifth power. We have the next number. The next number is a decimal. Therefore, we have a negative exponent. The first non-zero digit is 6. This is 6.3. Then we count the number of digits to the left. 1, 2, 3, 4. We have 6.3 times 10 raised to negative 4. Now we have another number. We have 9,000. We have 3 zeros. That is 9 times 10 cubed, or to the third power. We have 800. This is 8 times 10 squared. Next, we have again a decimal, which is less than 1. So this will become 3.8. From the decimal point, we move to the left. We count 1, 2, 3, 4. So we have 3.8 times 10 raised to negative 4. We have the next number, 86,500. The first non-zero digit is 8. So we count the number to the right. So we have 6,500. We have 4 digits. So we have 8.65 times 10 raised to the fourth power. Next, we have 4 million. In 4 million, we have 6 zeros. 4 times 10 raised to the sixth power. Next, we have 5.75. This is already 5.75. So what will be the exponent? This can be written as 5.75 times 10 raised to 0. Why 0? Any number raised to 0 is 1. 5.75 times 1 is still 5.75. We have the given number, 26 millions and 26 millions. So from 2.6, we count the number of digits to the left. 1, 2, 3, 4, 5. We have 2.6 times 10 raised to the negative 5. All right, we have 45. This can be written as 4.5. So 4.5 times 10 raised to the first power. Because 4.5 times 10 is 45. All right, we have another number. Write the following numbers in decimal notation. 2.3 times 10 raised to the 7. We have already 1 digit here. We need another, so this is 7. We have already 1. We need 6 zeros. 23, then 6 zeros. Then this is negative 3. We have already 1. We need another 2 zeros before 6. So this can be written as, so 0.0069 or 69 thousandths. So we have 3.1 times 10 squared. 10 squared is actually 100. 3.1 times 100 will become what? So 3.1 times 100 will become 310. Next, we have 2.86 times 10 raised to negative 6. This is already 1. So we need another 5 zeros, all right, before 2. So we have 5 zeros before 2, all right, and we have 286. Now, 7.11 times 10 raised to the first. So that is 10 raised to the first times 10. It will become 71.1. Now we have 6.25 times 10 raised to the fifth. We have already here. The exponent is 5. So if we have 2, the exponent is 5. We need 3 zeros to make it 5. All right, next we have 7.51 times 10 raised to negative 9. This is already 1. We need the 8 zeros before 7, no? To make it negative 9. All right, let's count. 1, 2, 3, 4, 5, 6, 7, 8. And this is the ninth one. Now, the next number, 5.85 times 10 raised to the 0. Any number raised to 0 is 1. So the answer is still 5.85. Next, we have 4.23 times 10 raised to negative 2. This is already negative 1. We need another 1 0 before 4. So we have 0, 4 to 3. Next, we have 5.19 times 10 raised to 7. We have already 2 here. We need another 5 0 to make it 7. So we have 519, then another 5 zeros. So